Hello, this video is to explain investigation 1, testing the physical properties of an LDR. Now this little device here is the LDR. An LDR is an acronym for Light Dependent Resistor, which means that the resistance changes with light. So I'm going to bring the camera a little closer so you can see what I'm talking about and give you some ideas for your investigation. Okay, so here is the LDR itself. And as you can see, that's just a very small component. And this measures the resistance due to the light intensity. Okay, so what we're going to do is we're just going to take this LDR, I'm going to plug it into our multimeter. The multimeter, then we're going to switch to measure the resistance since it's a light dependent resistor. So now that means that you've got one possible dependent variable being resistance. You could also set the LDR up in a circuit and measure voltage or current through it. So we can see here we switch it to 20 kilo ohms or even 2 kilo ohms, we're getting a resistance here. Now that's actually because there's quite a lot of light here. I don't know if you can see, but there's quite a lot of light here. Hopefully you can read that this is reading around about 5.6 kilo ohms. Now I'm pointing this towards the light, so that's going to be quite bright. If I point it away from the light, we see the resistance increases to just about 1.4 kilo ohms. Now, one of the possible experiments you can do is take a flashlight or a torch here, and you can shine, oh sorry, this is a wind-up flashlight, so you can see that that's giving off light. Okay, so you could look at how resistance is affected with the distance of light, and you can see that the resistance is increasing as the distance between the light and the LDR also increases. So that's one possible investigation you could do. Now, originally one of the standard light experiments in science is actually candles. So you may wish to use a candle. And you could check how the light intensity changes with the distance from a candle. Of course, you'll want to control many variables if you're going to do that. You don't want ambient light, for example. You may want to set this up so it's a dark environment, all the rest of it. Another possible experiment that you could do would be to have your LDR here, and perhaps you could change the angle over which the light falls on the LDR. So you could see how the resistance of the LDR changes with the angle at which the light is incident on the LDR. Fantastic. Another idea is, here I have a polarizing filter for a camera. You could put the LDR behind a polarizer and check how the orientation of polarized light affects the resistance of the LDR, and you can see here that that's actually changing as I change the orientation of the polarized light, which is really interesting. Now of course our options don't start there. Here I have several different what we call LEDs or light emitting diodes. I just pull that down and I plug this into my battery. You see that we have two bright lights here, a blue and a green. Now the color of the light is essentially related to the frequency of the light, and therefore you could find the frequency of these LEDs. And by using our LDR here, we could compare frequency to the amount of resistance. Of course, I'm not controlling any of these experiments, I'm just giving you ideas. If we put this in here, hopefully that will give us... Now just pull these ones out here. You can see here we have more colours here, so we've got red, we can test with red, orange, green, yellow, and this is going to vary our resistance. So you could do some kind of investigation where you're looking at the frequency and resistance. Of course, could try a similar idea. If we bring in a computer here, and on my computer I've got, can you see this? I'll bring it in a little closer. So on the computer screen here I've got several colours. Getting quite a lot of reflection from the background here. So of course you could then measure how the LDR responds to, say, green, magenta, blue. So you could essentially vary your the colours on your computer screen and measure how the LDR changes its resistance. So that's very similar to the frequency situation with the LEDs. Finally, of course, the LDR here needs time to change its resistance reading. So we could look at a situation where we have, here's three LEDs here, and I've got this attached to an Arduino board. And if you like to challenge yourself, I think this is a good little challenge. Take my battery here, just plug that in. Plug that in here. And hopefully the camera's picking this up. We've got 3 LEDs here, and each is giving off light with a different frequency. This one's a slow frequency, this is a faster frequency, and this is a very fast frequency that it almost looks like the light is constantly turned on. That's like the light from a power supply, for example, has a frequency of 50 Hertz. We don't see it turning on and off because our eye has what's called persistence of vision. Okay, just so we could measure the resistance at a high frequency, which is 0.5, at a lower frequency, 0.7 approximately, and a very low frequency, we're down to about 0.6. So there's another option that you could do. So there is plenty of things for you to explore with this LDR. You need to choose a independent variable, one of these ideas. Hopefully you'll get something from one of these ideas, and a dependent variable, which is most likely for you going to be the resistance of the LDR. But once again, you could put that into a circuit and you could measure, say, the voltage through the LDR or the current through the LDR. You might want to look at if the LDR obeys Ohm's law, for example, with a constant amount of light. Honestly, this experiment is up to you. This investigation is your choice. Well, thanks very much for listening. I hope this has been useful to you, and good luck, and I look forward to hearing about your investigation.